Hello, my dear students. Welcome to the another episode of Classroom. So today onwards, we are entering to chapter 2, functions. Let's move to our PPT. First of all, introduction. So what is a function? A function is a block of code which only runs when it is called. That means if I am writing a a big program having a large number of lines, and in my program I need to uh, run a particular message in between the program. So what I will do, instead of writing this message on every line, I will make it as a function, and I call that particular function whenever I need it. Understand? That means if we need to repeat some computation or a sequence of statement, we need to repeat. What we do is we will write it as a function and we will call that function whenever we require. That is actually the function. So a function is a block of code which only runs when it is called. Okay. A function is a named sequence of statement that perform a computation. So a function having a particular name, okay, and it performs some computational process. So it having some name and it having certain blocks of codes. So all the codes are executed sequentially from top to bottom by Python interpreter. That means each line of the code is executed from the top to the bottom. That we have already seen what is sequential coding, right? The function can be categorized as modules, built-in or user-defined. Clear? Do you remember this one? This is our first program written in test.py. Do you remember this one? If you are not seeing that video, I will put the link in this here. Okay, please go and see that video. I will explain this once more. So DEF means it is actually the keyword. Okay. In order to define a function, we require a function body. This is our function body. We are defining what are the functions or what are the calculations or computation that a particular function has to done. Okay. For that, we are first using DEF. DEF is a keyword. After that, the function name, the parenthesis and a full colon. So this is a syntax of writing a function header. Okay. DEF, that is the keyword. Then after that, function name, parenthesis and a full colon. Clear? After that, we are writing the function body. In this function body, x assigned 2, y assigned 6, z assigned x plus y. Clear? Then after, printing z. Okay. So after that, we will file and then save this one as test1.py. Then after that, we will click run. Then after we get this Python shell, here we are writing test, that is the name of the function. So what we will get, we will while calling this test function, the interpreter will check where is this function and will directly move to this function and it will execute whatever be the operations or computations that we are written in this test function. So what is happening here? Here first x assigned 2, y assigned 6, then finding z, and that is x plus y, and the result is printed in this Python shell. Is it clear? Now module. A module is a file containing Python definition or a function and statement. That is, this module containing file that having the Python functions and a statement. That means we have already seen that our test. Okay. The standard library of Python is extended as module to a programmer. So here, for example, we have a standard library name math, math. It having all the mathematical operations such as finding the power of number, square root of number, sine function, cosine function, etc. So all these, all the computation related to a sine function or a cosine function, or how to find a power or a square root, all the step-by-step process is explained or the codes are written in the math file. Okay, so math is actually a module. This is standard library of the Python, and every computation is written inside it, it has saved as a function. Okay. So the definition from the module can be used within the code of a program. So the sine or a cosine is actually a function inside the math. Okay. So whatever be the definition, that means how to find a sine function is already defined within this module. So if you are calling that sine function, what happened is whatever be the definitions written in that particular program will run here. Okay. To use these modules in the programmer, a programmer need to import that particular module. Is it clear? That means if I have a math file, okay, or a math function, and in that math I have to use square root. In order to use square root, first I have to import that math module. Okay, that is this point. To use this module in the program, a programmer need to import that particular module. Once you import a module, you can refer or you can use any of its function or variable in your code. Okay, in a program, once you are importing this module means our math function, we can use all the functions in or variables inside the math standard library in our program. It's clear? It's a module. There are two ways to import a module in your program. First one is import itself. Second one is from. Okay, we have already seen this to import and from in keywords. So import is used to import a particular module to our program, and from is to specify what functions inside the module is used. Let's see in detail. Okay. First one, import. It is the simplest and most common way to use a module in our code. Okay, this is the simplest and a common way. Its syntax is import module 1, module 2, module 3, etc. So, example, import math. Okay, math is already an inbuilt library in our Python. On executing this particular statement, what the Python interpreter did is it will search for this math.py file. It will search where is this math.py and it create a space where all the functions and variables will be created. Okay, we'll check what are the functions inside it, what are the variables inside it, and it create a particular space for it. Then what happened is it will execute the statements in that particular module. Okay, in this math.py there are particular modules or we require a particular definition, it will execute that particular definition. We'll see with an example. Okay, the definition of the module will become part of the code in which the module was imported. Okay, to use or access invoke a function, you will specify the module name and name of the function with separated by a dot. That means first we have to write import math. Okay, so our aim is we need to find the square root of a particular number. First what we have to do is we will import that particular module. Clear? That means import math. Math is our module. Then in that math module we have some function that is a square root. That is math dot square root. That is, this is a module name and this is a function name. Okay, within that module we are invoking or accessing that particular function only. Clear? Within that module name we are accessing that particular function. This can be done using a dot function. How we are putting the dot? Module name. Okay, module name dot function. Okay, module name dot function. We can access a particular function in that module. Okay, this is known as dot notation. See, first we have to write import math, then value assigned math dot sqrt of 25. What will be the result? We will get the square root of this 25 and this value will be assigned to value, and if you are writing print value we will get the value of square root of 25. Is it clear? Now one more thing is the expression or variable within this parenthesis. is known as argument. Okay, here we are directly giving the value here, so it is known as actual argument. So clear? The expression or variable inside this parenthesis is known as argument, and here we are giving the direct value, then it is known as actual argument or true argument. Clear? There are some more functions that type int etc. Okay. Now next one is from statement. It is mainly used to get a specific function in the code instead of the complete module file. See, we know that the complete module file is very large. If you are required only a particular function, a particular variable or a particular definition, what we have to do is we are using the from statement. Okay, why we are using that full import? That is, we only using the from statement if we are knowing the specific function. Okay. So the syntax is from, module name, import, function name to etc. Okay. Is it clear? The module name means the bigger file. Okay. Is it clear? Module means the bigger one. Function means whatever be inside that module. That is its function. Okay. First of all, we have to write from the bigger or the parent file, that is math file, math, then import sqrt. Okay. It's an example from module name, import, function name 1, 2, 3, etc. Okay. From math, import, sqrt. Value assigned sqrt of 25. Okay. This is also used to import a particular module. Is it clear? Let's see the examples in our Python intermediate mode. First of all, import math, value assigned math.sqrt of 25. So here we are using math function. After that, the module, this is a dot notation, module dot function. Then we got the values 25, 5. This is the usage of from. So from math, import sqrt. Same thing, value assigned sqrt of 36. We got the square root of 36. It's clear? Let's explore some more functions available in math module. Okay. First one is ceil of x. It returns the smallest integer but not less than x. Okay. It will return the smallest integer but not less than this x. That is ceil of x. Let's see some example. First of all, we are importing math. Then math.ceil minus 45.17. But what is happening is it will return the smallest value but not less than this one. Okay. So we get minus 45. Here math.ceil 100.12. So it will return the smallest integer but not less than this one. That's why 101. Then math.ceil 100.72, it will also return a smallest integer but not less than this one. Okay. It will be slightly greater than x. Okay. Is it clear? The next one is floor of x. It returned the largest integer not greater than x. So first of all, we are importing math. Then math.floor minus 45.17. What is this? It returns the largest integer but it is greater than x. We got minus 46. Then math.floor 100.12. It will return greater integer but not greater than this one. Okay, slightly less than this one. That is 100. Here also slightly less than 100.72. That is 100. Okay. Here also slightly less than this one. That is minus 46. Since in negative numbers, minus 46 is less than minus 45. Okay, it's clear. Also, here also minus 45 and this one minus 45 is greater. Okay. The next one, fabs of x. It returned the absolute value. That means it is only returning the modulus value or the root or the positive values, not the root positive values. That is it is returning the magnitude only, not the sign. Okay. So whatever be the number inside this bracket, we are getting the positive result. Okay, or the magnitude only. So math dot fabs of minus 45.17, the answer is positive number. Here also in the both case, we got the positive number. Clear? Before that, we are every time we have to import this math function. Okay. Next one, exponential of x. We already know that exp means exponential of x. We get e raised to whatever be inside this parenthesis. Okay. First of all, import math. Then math dot exp of minus 45.17. We got the exponential function. Similarly, we can give any number and get the corresponding exponential functions. Okay. Exponential value we got. Okay. So clear? Let's move to the next one. Log of x. It will return the natural logarithm of x. Okay. So, first import math. Math.log 100.12. We got the answer. Then, math.log of 1. We know that log of 1 is 0. Similarly, the math.log 100.72. We got the answer. Okay. Next one is log 10 of x. So here it returned base 10 logarithm of x, where x is greater than 0. Okay. Here first import math. Math.log 10 of 10. That's value is 1. Then math.log 10 of 100.12. Then math.log 10 of 100.72. We got the corresponding answers here. Okay. Next one is power xy. It returns the value x raised to y. So x will be the base and raised to will be y. Okay. X raised to y will be returned. Let's check some examples. Import math. Math.power 100, 2. That means 100 raised to 2 will be the answer. Here math.power 100, minus 2. So 100 raised to minus 2 will be the answer. Then math.2, 4, that is 2 raised to 4. Then math.power 3, 0, 3 raised to 0, that is 1. Okay, is it clear? Next one, sqrt of x. It returns the square root of x for x greater than 0, where x is a numerical expression. First, we are importing math. Then math.sqrt of 100. We got the square root of 100 as 10. Then square root of 7. We got the answer. Okay. The next one is cosine function. So return the cosine value in radians of this x. Okay. So math.cos of 0 we got 1. Then we are checking some other values. Here all the values are in radians. See here math.cos, math.pi, that means 180. Okay. Math.pi means the value is 180. Okay. We got the answer. So all the values are in radians. Sine of x means it returns the sine value of x in radians. So we are checking some examples. We are finding the answer of sine 3, sine minus 3, sine 0. Okay, you can also check it using your scientific calculator. Okay, you can check sine of 3, whether both answers are same or not. Okay. Next one is tan of x. We are getting, it will return the tangent of x in radians. Here also we are checking tan of 3, tan of minus 3 and tan of 0. Okay. Next one is degrees of x. It convert angle x from radian to degree. So whatever be the answer in this x, it will return corresponding degree. So math dot degree of 3. We are getting degree of 3. Here this 3 is in radian, so we can convert this radian into degree. Okay. Next one is radians of x. So here this will be converted into, this x will be in degree, it will be converted into radian and return the answer. Okay. Here see, here we are finding some degrees of some radians of 3, minus 3 and 0. Okay. Let's see some function from random modules. Random numbers means we are randomly or taking some numbers. It is not definite that this number will come or this number will come. It will be in random manner. Okay. First one, random function. In return is random float x. Okay. In between 0 and 1. Okay. We'll check what are the random numbers we obtain. First of all, we are importing random. Then random dot random. Okay. This is a module name and this is a function name. Okay. So first we got a 0.662 something, and then second time we got another number in between 0 and 1. Okay. Next is rand int a comma b. That means it returns a integer x between a and b. Okay. That means a number between these two limit. It is in integer form. Okay. So random dot rand int 1 comma 10. That means a number between integer number between 1 and 10 will be displayed. Okay. Here also in between -2 and 20 a random number integer number will display. Okay. Next one, uniform a comma b. It returns a floating point number x such that a less than or equal to x less than or equal to b. That means it's also returning a uniform number in between two limit. Now of case first random, it is between 0 and 1. Here it is between two limit. Okay, that's a difference between uniform and random. So random dot uniform 5 comma 10, it will return a random floating number between these two limit. Okay. Next one is rand range. It returns a random item from a given range. So in this range we have a start, stop and a step. Okay, let's check with an example. Random dot rand range 100, 1000, 3. 100 is a starting point, 1000 is a ending point, 3 is a difference. Okay, 100 after that 103, 106, 109, that is the common difference is 3. So we are getting a random number 982. Next one, random dot rand range 100 to 10,000, the range with the step of 5. So we got 6690. Clear? This will be random value. If I am again writing the same step, the next time the number will be changing. Okay. So for more doubts and notes, please mail me to this mail ID, and please don't forget to subscribe our channel for more videos. Thank you.